In this video, we're just going to talk about one version of a DC motor. And DC just means direct current. Um, and there's no reason you should know what that is yet. Okay, so here I have, this is a battery. And you know current's going to go from positive to negative. So it's going to flow around this loop here, which is a wire, and come back to this negative side. And now you'll be able to see in this picture a commutator a lot better than what I could draw. The kind of half circle here is connected to the wire on this side. And the half circle here is connected to this wire. The current, right, the battery is hooked up to this wire. And for the current to flow, this brush, what it's called here, this brush has to be in contact with this commutator. And if they're not touching, there will be no current. And you also see that if this flips 180 degrees, the current will stay in the same direction. And this is also, I think we have the current going in the opposite direction than what we had in class, but it should make sense either way. And so I have a magnetic field going from here to here. Don't worry about the north-south bit yet. So we have a magnetic field going this way. And if our current is going this way, away from us, in this red section, I can see that the force is going to be down. And in here, again, it doesn't really make sense because the current is parallel to the magnetic field. On this blue section coming back, the current's coming towards us, the magnetic field's still going to our right, and so the force is going to be up. What this is going to do is it's going to twist the motor so that the blue side goes up and the red side goes down. And in the second picture, that's what you see. And now we have the blue side up and the red side down. And again, just because of the forces on those two things. Now the brushes here are no longer in contact with the commutator, these rings over here. So there's no current. So it's just chilling. But because you got it spinning, it's still got some motion, right? First law, Newton's first law. So it's going to keep spinning until it gets down here. Now it's flipped 180 degrees. And here's the really important part about the commutator. The current is still going to go like this, what I would call clockwise. And that's because the battery is still got its positive side on this side and its negative side on this side. And the only difference is now that the thing is flipped 180 degrees. So again, the current is going this way up here and backwards over here, and so it'll give you the same force. So it'll keep spinning. And that's a motor. And these have tons of applications. So basically, most things that you plug in and they move, they work in some way related to this, and that's a lot of things in our society. And I'll show you guys an animation of what this looks like. And I'll show you the URL here, so if you want to go check this out by yourself. Got our battery, and this is oriented just like how we had it in the picture. And you can see the current is always going to flow in the same direction, even though it's flipping 180 degrees. And there it is spinning. And again, you can see the current direction when it stopped here. Another version of this is just another look. And again, this might be useful to you. And you can see that it's got its force there, and it kind of spins through, force there, spins, force. And the force is only there when the current's going through, which is when these blue and these black things are in contact. And these would be the brushes and the commutators. And contact, right? And do I have another one? Okay. This one. This one's just flipped 90 degrees. And again, it's showing you the blue is the magnetic field, the black is the magnetic force, and the red is the direction of the current. And so an interesting thing to see here is that if there were no commutator, right, once this flipped 180 degrees, the current direction would flip. But that would change the direction of the force. So you'd get something that would look more like, so it's force there, whoa, whoa. Something that would look more like this, right? So the direction of the current would change every time it flips. So your motor would just kind of go back and forth. Not very exciting. And that's the DC motor. And again, that's just something that you might want to practice right-hand rule it out.